In this video, I'm going to explain how to apply the properties of exponents to division. First of all, what do exponents mean? For example, this problem x to the 6th over x squared. Well, x to the 6th means x times itself 6 times. And similarly, x squared is x times itself twice. So we can expand this problem out to get a visual representation of what's happening. Remember that x over x for any number is going to equal 1. So anytime you have an x in the numerator and an x in the denominator, you can sort of cancel those out. They're going to just become 1, and you don't need to mention them anymore. So when we do that to this problem, that leaves us with 4 x's in the numerator, which we can write as x to the 4th, and nothing, just a 1 in the denominator. When the denominator is just a 1, we don't really have to mention it. You can just write that as x to the 4th. Now notice in this example we did expand it all out, but the exponents themselves kind of give away the answer already without expanding it. You notice that there's a 6 in the numerator and a 2 in the denominator, and if you subtract 6 minus 2, that gives you 4, which is the exponent we used in the simplified version. So you really don't have to expand it all out like this. You can just use the exponents and subtract them to find the exponents in the simplified version. Here's another example that you can solve without writing x out 9 times and 5 times in the numerator and denominator. You can just subtract the exponents. 9 minus 5 gives you 4, meaning that the simplified version is x to the 4th. Okay, so in those examples, the exponent in the numerator was greater than the exponent in the denominator. But what if that's not the case? What if the exponent in the denominator is greater than the exponent in the numerator? For this, let's expand the exponents out again, just to see what's going on. After canceling out the pairs of x's in the numerator and denominator, you can see you're left with x to the 5th in the denominator and a 1 in the numerator. Now because there's nothing else in the numerator, you want to leave that 1 there. This is different than when we got rid of that 1 that was alone in the denominator. For a 1 in the numerator with nothing else going on, you want to leave that 1 as a sort of placeholder. So what if there are terms with different bases in the numerator and the denominator, like in this problem? The important thing to know is that only terms with the same base are going to have any effect on each other. So for example, this x to the 4th and y to the 3rd are not going to have any effect on one another. So if you look at the terms that have the same base, x to the 4th and x squared, same as we've been doing before, the greater exponent is in the numerator, so that's where that term is going to stay, and you can subtract the exponents. Same thing with y to the 5th and y to the 3rd. The greater exponent's in the numerator, so that's where that y term is going to stay, and the exponent will be 5 minus 3, or 2. Here's another example of that type with a mix of different bases. You can see that the greater exponent for a is in the numerator, whereas the greater exponent for b is in the denominator. So the a term is going to stay in the numerator, and the b term is going to stay in the denominator. Okay, now suppose that there are also coefficients in a problem like this. The way that we deal with these x and exponent terms is going to be just the same as we've been doing, but after you deal with that, take a look at 2 over 3 and think about if there's any way to reduce those numbers. Do they have any common factors? Anything that can divide both of them? In this case, no. So they move along to the simplified version of this problem in exactly the same way. 2 in the numerator, 3 in the denominator. If those coefficients do have any common factors, then you're going to want to reduce that. So first we can deal with the y terms just the way we've been doing. You can see that the greater exponent is in the numerator, so the y term will stay in the numerator, and the exponent will be 8 minus 3, which is 5. Then you can see that 5 and 10 can both be divided by 5. 5 divided by 5 is 1, 10 divided by 5 is 2, so that's going to put a 1 in the numerator and a 2 in the denominator. Now in contrast to a previous problem, you can see that in the numerator there is another term besides that 1, which means we don't have to keep that 1. It sort of becomes invisible. You can just have y to the 5 in your numerator, and the denominator will be 2. Here's another example. You can see that we can deal with the m terms just the way we've been doing. M cubed in the numerator and m squared in the denominator. 3 minus 2 is 1, which means that the term that's left will have an exponent of 1, which we typically don't write. M to the 1, we're just going to say m. 16 in the numerator and 8 in the denominator have a common factor of 8. So if you divide those both by 8, it's going to put a 2 in the numerator and a 1 in the denominator. And here, as before, the only thing in the denominator is 1, which means we don't have to write it. We can just leave the simplified version as 2m. In this last type of example that I'll show you, you can see that in the numerator, there's actually multiplication of terms that have the same base. So before we start applying the exponent properties of division, we can simplify the numerator to make our job a little easier. So that x to the 5th and x to the 3rd, we can apply the multiplication properties of exponents and turn that into x to the 8th. The 6 is going to stay a 6, the y squared will stay a y squared for now because we're just focusing on the numerator and there are no other terms with a base of y in the numerator. In the denominator, you can see that none of those terms have the same base. Y, m, and x are all different, so for this step, those will all stay just as they are. Now that the numerator has been simplified, we can go ahead and apply the exponent properties of division. So x to the 8th in the numerator, x to the 4th in the denominator will become x to the 4th in the numerator. Y squared in the numerator and y to the 7th in the denominator will become y to the 5th in the denominator. Notice that there's only one m term in the denominator. There's no m term in the numerator, so that m term is not going to change. It will just stay m squared in the denominator. 6 and 10 have a common factor of 2, so you can divide them both by 2, leaving a 3 in the numerator and a 5 in the denominator. I'm going to write one last example. I suggest that you pause the video, try it yourself, and then compare your answer to mine. I hope this was helpful. Thank you for watching.